Oh, it's you.
How are you doing? Ready?
Yeah. So he's going to go after large models, ChatGPT with human attention, so origin.
We'll cover that. Much like the loss, actually lost one, but I'll do like the full engineering.
Amazing. Yes, that's really good. Great. So I'm going to do two. Very, very.
Just gonna improvise about it.
Series. So yeah, cool. Silicon Valley founded, of course. You also talked about the NVIDIA Institute. So you're on a mission to make for 1 minute to teach 1 million people machine learning engineers to accelerate, to help a million people accelerate. Oh, accelerate careers. What do they be? That's good. And what else? Yeah, I think it's pretty much it. Exactly. And it was very fine for great stuff.
Because when you use the right, it becomes really the other one, really good. The German one?
Oh, yeah.
They just so once you get it's like it's having a rotation. Exactly. Yeah. You mentioned it like yeah. Well, then they already right.
Today we had a quite structure. We invited the studio of you click on the top, wait.
Yeah. What's his name?
Matt's exactly Matt something. Yeah. Oh, you know Matt. Yeah, so and yeah, maybe some other village.
Yeah.
It's a first session, yeah, right? It's gonna attract people, etc. Advertising nearly as bad well as first edition. First edition was everywhere with the edition street. City one, and it's it also it's fun. This is just part of it's also language, machine, and yeah, I mean, if you want to remember, it's something like it's on Tuesday, so I don't know if you're doing it. But if you're around at some point, it's Tuesday at 11 a.m. It's every Tuesday for your book club. But yeah, it's what you do. But yeah, we're just around. Take a seat. Oh, you can do this right now. Yeah, we should.
Give it a minute actually, because Pamela might be.
Yeah.
We're just gonna give it a minute, guys, and make sure everybody filters in, and then we'll get started. Thank you.
All right. Welcome everyone to this brand new edition of the machine learning series by Harry Berg from AI Core, co-organized as well by Andre and Thomas. By popular demand, there's a brand new edition. It was very popular last term. If some of you had the chance to attend it, people really liked Harry's teaching style, his enthusiasm, his energy. So you're in for a treat. Don't want to a lot of pressure on you, but you're in for a treat. And okay, so Harry basically is the founder of AI Core, a Silicon Valley-based Silicon Valley startup, and his mission is to basically empower 1 million people to achieve the most in their career. He's on his way basically. He's been teaching at many prestigious universities in the UK, including Oxford, UCL, Imperial. He's also taught at the NVIDIA's Deep Learning Institute. So you're in good hands. Thank you, Harry.
Thank you, Eunice. All right, cool. Let's get started. Sorry for the slight delay with that. And I think, yeah, over to me now. So what we're going to talk about today is aligning large language models like ChatGPT with human intentions. It's a big topic and there's a lot to get into. So really, I want to kind of start off like, where are we on this long arc of AI development? So, obviously massive progress recently in large language models. It's pretty much the only thing anybody is talking about right now. ChatGPT has become a household name, and that makes my job very easy. All I have to know about is ChatGPT and share how that works. Or in other words, all I have to know about is how do the most complex systems ever built by people work from a theoretical level, an engineering level, and a business level. Come and stand up on stage in front of some of the brightest minds of our time at the most prestigious universities in the world, like this place, Oxford, go through the theory and live code in front of everybody. Easy. So with that, I want to kind of give an overview of what I will take you through today. So this is the main topic. This is me. You already know. I'm Harry Berg. I'm from AI Core, and you're all here to build the future. So this is kind of a quick cross section. I should have made that bigger, but it's a cross section of what I want to do today. So really, I want to take a look at things from 3 different perspectives: from an executive understanding, from a theoretical understanding, and an engineering understanding, and then look at kind of 2 levels of depth for each of those. That is, what is alignment, and then the RLHF implementation, the implementation of how the main approach here works. So that kind of cross section, really 6 different sections. And what I want this to be for you, because I know we've got people from a lot of different backgrounds here, is really like build your own lecture by paying attention to which different pieces you want, right? So if you are coming from, you just want to appreciate things from a high level, then you can just look at the executive understanding pieces. If you're really here to understand the detailed implementation, pay much attention to the engineering. And if you want to pick any combination of those, just let your focus be there. And hopefully as we go through things, I'll be able to provide you some things to do and pay attention to if you don't want to dive into some of the other sections. So that's really what we're going to go through. Firstly, like I said, I'll go through what's alignment, talk about like what kind of products that enables and some of the risks on different levels as well, which you should be aware of from the highest level possible. And then talk about what that means theoretically. So what are we actually trying to achieve with solving this alignment problem after I describe what that is. And then an overview of the different approaches to the alignment problem before we dive into the main exciting application, which is RLHF. So I'll talk about the overview of the different teams and tools and the data sets that you need to make that work. Again, that'll be the high level look. And then I'll talk about that from the theoretical perspective. What do you actually need to do to make that work? How does that work behind the scenes? And then the engineering of how do you actually put that into practice? So I'll talk about a few different tools there and do some demos as well. If you've been to any of my lectures previously before, they've been very hands-on and very intense. I'll try and keep this one a little bit lighter, but also provide you a path to get into some of the details if you do want to kind of really get hands-on with the code. But I know I said no prerequisites to this session, so don't feel pressured to do anything, or don't feel scared if there's something which is too much for you, whether it's the code or whether it's the equations that we look at. Really, yeah, make it your own. Any questions about that before we get started? Anybody want to contribute anything? All good? Nice. So, what is alignment, firstly, from like the high-level executive understanding? Before we talk about that, just to introduce glossary term, LLM, I'm going to use that constantly throughout. LLM stands for large language model. That is all of the recent work you've seen in ChatGPT. That's a large language model. GPT, you may have heard of others, which I will show in a second. But at a high level, what does an LLM do? It takes in a prompt and it provides a response. So text in, text out. That is the language modeling problem. It's can you predict what comes next, basically? Can you generate the text? So any kind of models that you see doing that, that's a large language model. And so these are a few of the examples, a few of the names of kind of the biggest ones that you may have heard of. Obviously, GPT, that's the GPT in ChatGPT. Palm, that's Google's Pathway language model, another just really big model doing the same thing with Google's name on it. Megatron, sinister sounding, not sure why they picked that, but that's NVIDIA's large language model, I believe. And so, basically there's loads of them. There's loads of them. I only put down 3 here, but you can find so many big companies, so many research companies coming up with their own models. Some are open source. They're all different in some kind of ways. But they're all these large language models. And all of these LLMs, they are enabling all kind of new products. So ChatGPT would be probably the most prominent example. But that's really powered under the hood by GPT, which is now available as an API. So you can make requests to OpenAI and say, hey, can you complete the prompt for me here in code? And then you can get the response back and you can build that into all kind of products. So to look at a few of these, there's some really good examples which I think will kind of illustrate the point of how impactful these LLMs can be in creating new kind of products which have never existed before. So you may have seen some of these examples, but to take you through them, this one, for example, is called Be My Eyes. And what it does is for the visually impaired, they can use their camera to take in an image and GPT describes it. Encourage you to watch the video on this page somewhere where you can really see kind of, how this is like transforming the lives of people who are blind and kind of, help them do all kind of everyday activities, which otherwise are just really hard. But being able to take vision, turn it into text, and pass that directly to somebody who can clearly understand the text, but can't understand the vision. This is probably my favorite example. Gaming and kind of content in general. Using AI to develop, like say here, the development platform for AI practices. They do a bunch of different stuff, like allow you to control the movements of stuff, make other realistic. But the exciting part for me is being able to create characters that have a clear, unique, and consistent personality. Being able to provide context for them to act in, so that you can have these really unique situations with. And there's a kind of very simple pathway of decisions that can be made to figure out, what the outcome for that character is. But with large language models, you can actually have like a real personality in these individuals. You can make all of them very unique just by changing how you explain the large language model to act. And so the way that would work is kind of behind the scenes, you're playing the game, you interact with a character, and that gets passed to a large language model in the form of a text prompt, maybe describing what you just did or describing what you just said. And then the large language model will then complete that text, maybe kind of trying to continue the story with what this character would do. And then that can play out in the game. So that's, I think, a really cool example. There's a bunch of different products that they have within that, and a lot of it's powered by these LLMs. So I'm going to come back to that as a running example throughout. Then maybe more on like a SaaS side of products for businesses. I think Viable is a good example. What they do is they allow you to taken qualitative written feedback from users and summarized that. So you can imagine you could just pass a big block of text from hundreds of users' feedbacks, and you could pass that in as the prompt to a large language model, and then follow that with like, hey, can you summarize this? And kind of get a large language model to give you the key insights without, as it says here, having to spend hundreds of hours analyzing that feedback. So that's really interesting. And then the final example I've got here, really close to my heart of education, is the Duolingo Max is a really awesome example where you can have role play dialogue, kind of infinite practice with an AI teacher. In this case, in the context of back and forth language, you want to explain, you want to be able to get as much practice as you can in a wide variety of contexts that don't have to be pre-scripted and kind of pre-written answers and all of that kind of stuff mentioned. So I think like this is the start of something really interesting. And maybe next time, like you won't need me here and I can replace myself with some kind of large language model. I think there's so many exciting opportunities across there. Has anybody else seen any other really good examples they can explain in a few sentences? Eunice, you seen anything good recently?
Yeah, you cited most of them, I guess. Thinking about some. Notion, maybe?
Oh yeah, Notion.
Using Anthropic code.
Yeah, yeah. That would have been another good example for me to put in the list of a few different large language models. Claude is the language model, isn't it? Built by Anthropic, which is kind of Google's version of OpenAI, right? And yeah, that's a good one. What are they using for in Notion? It's like making it easier for you to just.
To have idea, for example, you have a great list of, let's say you're taking notes about your history class, something like this, and you can't be bothered making full sentences. The AI is going to make full sentences.
Cool. Yeah. Nice. Yeah. Another awesome example. Anybody else seen anything interesting worth mentioning outside of that context? David?
Brancher.ai
What's that?
makes it really easy to build web applications without code. And
Okay.
hooks it all up.
Awesome. Yeah. Great application, right? So not only writing human natural language, but also programming language. Can you prompt it with natural language, I assume that is, to describe the site you want, and then get the designs of that completed in code. Epic. Yeah. So a lot of really interesting stuff. So I want to kind of just give some context as to like how you would do this in practice, so that we're all kind of clear of like what this actually looks like in a concrete way, because I know I can talk all day about it, but it might not be clear to people. So I've got a little thing prepared. We can kind of spend, I think, 15 minutes just doing this so you guys can all get hands-on with it. And then we can kind of move back onto this. But here's a notebook which I want us to open up in Colab. So I'll get there and then I'll show you how to do that. So if you just search Google Colab on your laptop, COLAB, you'll get to where I am here, and something like this. You can hit Open Notebook, and then you can go to GitHub. There's a GitHub tab over here. And if you search in there my username, which is life-efficient, then you can select from a drop-down of different repositories. And there's one called Aligning Large Language Models with using RLHF. If you hit that, it will give you a list of the different available notebooks in there. And the bottom one is this OpenAI API demo. So if you open that up, then this is kind of just a concrete example of how you would interact, how you could interact with one of these pre-trained large language models. So there's a lot of work been done by companies like OpenAI to make sure that they've processed a lot of data to make these things useful. And we'll have a look at that here. So take a second just to pull that up. Sorry?
What's your user again?
It's life-efficient. Let me show you what that is. So sorry, I wish I'd provided this in a more simple format, but that's me. So that's the link you want to go to. You can go on GitHub and then life-efficient, or you can go to Colab and do the reverse.
When we go to Colab, do we go to search, or can you go through it again?
Yeah, for sure. So yeah, just go Colab, COLAB, click here. And then if you go File, New Notebook, or if it comes up like this, then you can go to GitHub. And then if you search there, life-efficient, search that, it'll give you a drop down of the different repositories. You can just select this aligning large language models using RLHF. And then in that, there's a bottom one, which is the OpenAI API demo. So if you hit that, you'll end up here. Okay. Cool. Anybody struggling with that? Cool. All right, good. If you don't want to get involved with the code, again, make this lecture your own, and you don't have to jump into this if you don't want. But what I want to show here is just how you would use these large language models from OpenAI, for example. So the first thing you need to do to use this API, which is just a computer, OpenAI is running somewhere that you can make requests to, and it'll send you something back. It's as simple as that. You need some kind of credential to do that, so they know who you are, so they know how to bill you, so they know whether or not you have the permission to be using this system. So you need to get an OpenAI API key. So to get that, you can go to openai.com. You can go to the developers section. I'm pretty sure anywhere in there, you'll be able to find it quite easily. This is the API reference, which is just the documentation explaining how you can use the systems they have, basically how you can interact with GPT-3 or 4. And in there, we'll look at this in a second, but it explains how that works. At the top right, there's a little avatar up here. And if you click on that, you can go down to View API Keys. If you hit that, you'll be able to see your API keys. This is your credential, right? So yeah, if you want to kind of reach that point, you want to create a new secret key, and then you want to copy that into here, and you want to make sure you never share that with anybody, like I've done here. I've already deactivated this one, but just an example, this is how it should look when you get your API key. So try and go to OpenAI, generate the API key, and you want to replace that in here. Cool. Once we get into this, I'll come around and just help if there's any issues. But that's the kind of credential you need to use this. And then once you're there, you can actually just import all of the code that OpenAI has written by doing import OpenAI. Now this, when I run this, it might throw an issue. So let's have a look how to solve that. So firstly, you want to run this cell. So on the left-hand side, whenever you hover over any, you can press this play button. It's going to run the code in there. If you're not too familiar with Python, don't worry too much about the details. I'll be happy to explain anything that you're worried about, but I've tried to keep this simple and readable. So once I've run that cell, green tick there, next I want to import OpenAI and set the API key. That's what I'm doing down here. I'll just run that. I get this issue. You guys will get this issue too. It says no module named OpenAI. It's very easy to solve. I just want to go above here, create a new code cell. I need to install that thing that it's missing. It says it can't find OpenAI. So I do !, pip install OpenAI, and then run that. Anybody know what the ! means? Some of you do.
Run a command.
Run a command in which language? In Python? Yeah, in Bash, exactly. So the ! Means like this cell is not running Python. All the other cells are running the Python programming language. So this one is basically in the terminal of the computer, installing stuff into the operating system. So it installs that library for Python to access. So once that's done, I can run this cell, which should run Python code. And That works fine. Now I've set that API key. So from there, you can run this cell. This, how did I get this? What I'm trying to get here is the response to a prompt. I got this example straight out of the documentation. So really, I just want to give you the groundwork here, and you guys can go and build whatever you want on top of this. If you open up the documentation here, you'll be able to see exactly how all of this works. All the different configuration you can set, as well as, yeah, if you select drop down here, Python, you can get the exact snippet that you want. So here's an example of how to make that request. Like I said, how to make a request to OpenAI's computer. It'll compute the completion to the prompt and send it back to you. And that's what we get out of this response here. So if you guys want to run that and just play around with that, try and adjust these different things and put some different prompts in there and just get familiar with how that works. But it should give you a feel for, okay, this is how easy it is to interact with some of these large language models now that they've been created and made available through an API. In the meantime, I'm gonna set a working API key without you guys stealing it. Okay, cool. So I got a new API key. Now I can run this. And I got an incorrect API key here. Let me figure that out again. Not only do you have to put it in the cell on the top, you actually have to run this cell to set it as well. So I'm going to run that. That runs. And then this runs, and I should get some kind of response back. No, I've exceeded the quota again. That's not a good. It's not a good sign. It may be my billing as well, actually. So make sure your billing is set up. Right, this is on my personal account, that's why. So if you guys want to go ahead and set that up, have a play around with what's next, and I'll figure out mine at the same time. But what you'll see is that this code gets you this response. If you print out this response, then you will get some kind of values, and it'll probably look like a big chunk of stuff, you know, including, okay, when it was sent, some of the metadata, but also the completion for this prompt. And once you've done that, I've got a few challenges down there, which if you want to dive into, feel free. And you can do that throughout the lecture whilst I'm working through some of the other stuff if you're not so interested in that. So take 5 minutes, have a play around with that now, and take a stab at those challenges. I'll walk around, make sure everybody's set up, everybody understands, and then we'll get on with that. Sound good? Cool. I'll come to you in a second. Okay. Yeah, let me just think that up. Yeah, one thing to mention is that the billing is like super cheap. It's like 1,000%. Yeah, but it's I'm not sure that it'd be up. Yeah.
Yeah. Oh, right, yeah. So I think the setup is that you get a certain amount of field license, and you have to have um,
All right, so let's keep moving. Let's keep moving on through that. So yeah, I won't go into this now. Maybe I'll come back to it in a break, but I don't want to take up you guys' whole day. I definitely won't take as long as I planned. So I want to move on past this, but hopefully once you print that response, you'll begin to see like how you can get results from these large language models. And if you do a few of the challenges down here, which I've got, for example, some way to predict the sentiment of product reviews, or down here, something like, how would you go about creating the in-world example of asking characters to respond in a certain way in a game setting, you'll get the idea of how this can be used for different products. And this time next week, I'm going to be back here, and what we're going to do in that session is go through end to end using this API to build an example product and deploying it. That's the idea. So today I'll really talk about what's on the inside. Next week I'll talk about what's on the outside and how does all of that pack together to actually create a whole product from end to end. So I'm gonna jump back to my slides now, unless there's any other questions or issues people have got with that example and setting that up. Question? Sure. I'll need to set my API key though. So I will. Is anybody else, many other people struggling with that, or? Yeah, cool. A few other people. Right. So let's actually have a look at that then. So what I need to do here, I believe, is just set up a paid account. I'm an individual, and then I need to put in my details here. So I'm not going to show you guys this bit, but that's what I'm going to do. Okay. And now I would assume that because I've got my API keys, my API key set up, this one that I just created, I've got that in the notebook here. I should be able to run this response cell as my friend at the top successfully did. Let's have a look. I exceeded my current quota. Please check your plan and billing details again. Is there anything else I'm struggling with the rate limits? No, it doesn't look like it. Let's try with just another API key. Just gonna copy this one. So set the API key, install OpenAI, set that as my API key for OpenAI in this instance, run the response. Let's see if this works. So that one worked. I don't know what the issue was there, but just kind of that's the process from end to end. Make sure you got billing set up, make sure you got the API key set up, and make sure you've set that API key in your code. Does that answer that got you clear? Cool, great. So to look at that response then, let's just run this, and you can see, all right, this is the result. This is what the response looks like. Like I said, it's got a lot of metadata around it, and then it's got the actual text completion. What's the issue with this? Why is it so short? That's not very good. Exactly, yeah. So a token is, roughly a word, but maybe sometimes it's part of a word or a piece of punctuation. And 7 is not very many. So you can see here, there's probably 7 tokens in that. It's new line, full stop, and so on. So if I set that to maybe 700, then run it. Takes a lot longer. That's a lot more text to generate. Then I can run the next cell, and now my response looks like this, okay? So my prompt was, what was it? Create 10 taglines for an ad that sells ski goggles. Another business idea there, something people are already working on. But this is how this is actually happening for those companies behind the scenes. They've got code, makes a request to the API, that code responds, and it responds with some text like this. You could take that straight out and figure out how to format it in Python so that it appears in the way that you want it to. So you can see it kind of came out in this nice list. And I think, yeah, part of the challenge, probably before you do these challenges, would be, can you figure out a way to unpack that in a structured way? So, is anything anybody else wants me to show here? I can do some more code in front of people. Anything anybody's curious about or how it works or what's going on there? Question at the back? What's the error? Yeah, the rate limit error. I don't know. I mean, I think that was kind of what I was having as well. I'd just go through that process again of just check your account, make sure there isn't a rate limit applied on your account. There shouldn't be by default, especially if it's a new one. Make sure your billing is correct. Make sure your API key is correct. Make sure that API key is the one you've set in this notebook. So in the top cell, you might need to replace the one which I've left in there and then run every cell subsequently. If that doesn't work for you, I'll come and take a look in a bit. But we're not actually going to spend too much longer on this. I just want to kind of give that as a concrete example, right? So you guys can think that's what's happening in the background for a lot of these products. Now, like I said, I want to show this lecture like more of the inside, what's happening behind the scenes here. Next week, we'll use this to build something. Question? Different model, yeah. So this is all available in the documentation, but there's different models specialized for different things. Some of them are fast, but not as competent. Some of them are more competent. They have different prices and all that kind of thing. And you can find that in the API reference. I don't think it's this one actually. I think this is.
So you can go back.
Sorry, what did you want to say? Go back to. Oh yeah. Cool. Yeah. So here you can see, you know, a great point there. Like, look at the documentation. That's what I should have done. So if you're unsure of how anything works, you can find it all here, right? This is what the model does. And thank you. Yeah, that's exactly the right thing to do. So here you can use the list models to see all of my available models, and the model overview for descriptions of them. So that's what's going on there. Between list models and the model overview.
Yeah.
So list models, let's look at the difference right quickly. So list models, what does that do? Lists the currently available models and provides basic information such about each one, such as the owner and the availability. So I haven't used this in a while, but I believe what this shows is if you run this, you'll get like, okay, DaVinci, Ada, Babbage, they're all the names of the different models which are owned by OpenAI. Now, I think what you can do as well is you can kind of publish your own models on there so that you can access them for later. And so the way that you would do that is you'd probably use the fine-tuning API to create a fine-tuned model, and then that would appear in that list. And again, that's something we'll look at next week. Cool. Does that answer the question? Good stuff. Cool. Nice. Anybody want to dive into anything else? Was there another question I saw? Cool. All right, great. Well, feel free at any point if there's anything more we want to go through there. But that kind of concludes a quick demo, right? Just to get concrete on it. So back to the point of alignment, which is what we're talking about today. So aligned AI, what does that mean? It means AI that does what humans actually want, right? So there are a bunch of ways that it can go wrong and a bunch of things that you want your language models to do so they don't misbehave. And in practice, this is the reason why you see ChatGPT make responses like this. You know, it says, I'm sorry, I'm programmed to follow ethical guidelines. I can't answer that request. All of those kind of things. So where does that behavior come from? Because that's not the kind of thing that you find on the general internet data, which is what these large language models are firstly pre-trained on. You don't find sentences like this written. So the point of aligning them is so that they don't just behave like the comments they see on Reddit, but instead they behave appropriately by doing these kind of things, right? So, you know, not responding if it's not appropriate, or responding within constraints that don't kind of, say anything edgy or untrue if they're not certain about it. So alignment brings in this kind of stuff, right? It should help models that we work with to behave in a way that we actually want them to. And there are kind of there are not so big issues with this, and then there's like the doomsday sized issues with this, right? And there's a whole spectrum of things to worry about, you know. So on the very far side, there's the okay, what if AI develops its own agenda and begins to manipulate humans, or escapes the black box, those kind of scenarios. Won't talk too much about that today. Not really a pressing concern right now, in my opinion. But then there's also a lot of like much more present issues which are important to talk about, because these LLMs can pose risks if they're not aligned, even in some of the existing products which I mentioned, right? So to look at it from a few different perspectives, one risk is the usefulness of it. And this is more like, if you are running a business which has an LLM powered product, there is a risk of like your customers just not working for them, simply. So the usefulness risk is basically something like this, right? You have a large language model and it's just not very good, because you ask it to explain the moon landing to a 6-year-old, and then the completion is explain the theory of gravity to a 6-year-old, explain the theory of relativity to a 6-year-old. It is following the pattern, following the kind of pattern that you might see on the internet. Maybe there are pages where it's like, good questions to ask a 6-year-old or something like that. And this is the kind of thing, you don't want it just to directly model what it's used to seeing. Instead, you want it to be useful. And that's a kind of misalignment which we'll try and address this lecture. So, just to point out kind of a few of the top level risks of usefulness there. So there's like the lack of understanding context when users are trying to use it, inability to deal with situations other than what it's seen already, lack of robustness and error handling, and failure to prioritize user needs. This is basically your product doesn't work situation, which you want to avoid, because obviously that's a serious risk. If you are running a business, you have a reputation to uphold. It means that your product has to work. It has to have certain service level agreements, and this is not something you can afford to do for your brand, or just for the cost of running an expensive product, which doesn't really work. A lot of people taking pictures as well. I'll share these slides after, so you'll have access to them, but feel free, go ahead, take pictures. So another kind of key risk from top level is misinformation. Aside from just does it work, is it actually giving out truthful information? So here's another example. Explain why birds are not real, and the response is birds are not real because they are not made of flesh and blood. They're made of feathers, bones, and organs. It's had this kind of what people are calling a hallucination, where it very strongly and articulately explains something as if it were true, but in fact it's not. In this case, of course, it's very easy to see that this is not true. But in other cases, you can imagine it might not be so obvious, especially if you're using large language model for learning. You ask it why something is true, it's maybe going to explain some believable reason as to why that is. And there's a lot of examples of this going on, which I'm sure you'll be able to find easily. So that's an issue. And the kind of these misinformation issues are things like this. So just spreading false information, undermining trust of an organization or with an API or with OpenAI, reinforcing certain biases that are just not true factually, but may appear in the general data found online that these things are pre-trained on, and kind of hiding knowledge that people might want to get to by just propagating what is misinformation, essentially. And so the case here I describe as this is like, I trusted your product without realizing it was misleading them. That's the kind of situation here where you have this misalignment risk. And then I did have that slide may be in the wrong place. But the third one I'll talk about is just the inappropriateness risk, right? So I didn't include any examples here because I don't want to risk myself. But you can imagine the kind of things that are harmful, racial, like marginalizing to people, and you want to ensure that even if these kinds of patterns of language exist in the training data, you don't want that to come up, and you want to have language models that respond in the kind of way that dismisses this case and doesn't continue to talk about it and explain it in detail. So that was kind of the executive level understanding of what's happening with alignment. Anybody got any questions there? Want to dive into any of that? Cool. So what does it mean theoretically? That's what I want to talk about next. So this diagram, I think, is the key thing you need to know. I won't go too deep today, but essentially, every large language model is a probability distribution. It's going to respond to a request in a certain way, and certain responses are more likely than others. You'll probably notice if you've used ChatGPT, if you give it the same prompt twice, it gives you a different answer. And so that's just kind of with some certain probability, it's going to respond in a certain way. So that model is trained, like I've said, just on general internet data. So it's going to kind of follow that pattern of what it sees on the internet. And so I've drawn a diagram here with the x-axis labeled. Something over here which the data doesn't contain much of is gibberish. Something which it does contain is Earth is round. And something which it also contains, probably an alarming probability rate, is Earth is flat. So all these things show up in the data. And I think this is slightly unordered. Yeah, so this is my misinformation risk, so I'm going to skip over that now. So this is kind of what you get training on that data, right? So the yellow is what the data contains, and the blue is then what models respond with. They try and match that same distribution they've seen. And that's pretty good, right? It encodes a lot of general knowledge about human society into these models, because most of what's talked about online is, you can be certain that most of it is, it makes sense, it's literate, but a lot of it is probably biased or underrepresenting different things which we want them to respond with. And so the true distribution of what humans want might look something different like that. So the purple line I've introduced here is more like, okay, yes, please describe things like Earth is round with more probability and Earth is flat with less. So this would be kind of tackling the misinformation risk that I talked about. And then over here, you do want to zero the probability of this nonsense that comes out of the models so that you get good responses that are useful in the different ways that we described. So that's the misalignment there. It's the difference between those two distributions. One of them which models what's generally available online, and one of them is like what we actually want them to do. So the purpose of this alignment is to kind of is to bias the probabilities in a way that is more useful for humans. What does that mean? We'll discuss that shortly. So is that clear? Has anybody got any questions about that? Yeah. So why does that happen? Why does different responses to the same prompt? Yeah, why do we get different prompts, different responses to the same prompt? So what the output of these large language models is a probability distribution. So let's say there's 30,000 words which this model can predict as the next word. It's going to output a probability for all of them, and all those numbers sum up to 1, and they're all positive, so they're all probabilities. It's just going to sample from that distribution, and it does that randomly. So you might happen to pick one different word each time you do it. And when you roll that out, not just predicting the next word, but predicting the next 700 tokens, like we did in my example, then you can get very different answers, because obviously the next word is conditioned on the previous sequence of words, and that is determined probabilistically. Does that answer the question? Cool. I mean, I guess you could calculate you could actually get the probability with which the language model predicts each output, but I don't know how to describe what is correct and wrong. They are you could compare those probabilities, but it's a question of how representative is the data of what you want it to do. And that might be different in different cases, right? You may want certain applications where the answer is always the same, maybe in scientific applications, and it has to be truly confident. Or you might want to use a language model in creative applications, in which case you want to do more brainstorming and free thought and let it go to wherever it needs to go. So yeah, I think different situations might require different setups there. But you can change that. So let me say, let me bring this back to the example here. There's a parameter called the temperature. And so the temperature is a value which either makes the probabilities closer together or pushes them to their extremes. And I believe it's, yeah, the lower the number, the more deterministic that function is going to behave. So that should produce the same responses over and over again. So I have a question. Yeah. Mm-hmm. Yeah, I mean, this is like definitely like a very abstract kind of toy representation. Of course, like the different responses don't lie on a single line. Those responses are probabilities over 30,000 words over however many characters you want to predict for. So that's how many dimensions the space actually have. It's not just 1D, it's not just 2D, it's not 3D, it's more like 2 million dimensional or probably higher, right? And so this is like just a very big kind of open space of possibilities, and each point in that space represents the final response that's generated by the model. So it's very hard to look at and not really something that I can intuitively grasp graphically. Yeah. Mm-hmm. Yeah. So this purple curve totally depends on how you collect that data, which says what people want, right? So depending on who's labeling your data, or how much of it you have, or what examples you give it, this curve is going to look very different. And even for different groups of people, it's going to look very different. And kind of this is, I think, the big thing that OpenAI keeps talking about is like, they are trying to develop a general purpose language model, which kind of, is conventionally correct, but people will be able to use and personalize in their own domains. So maybe there's one, which is going to be, the American OpenAI, and maybe there's one which is the Italian ChatGPT, or maybe not. Different countries are going to have different restrictions, different preferences, different kind of, maybe they vote on it within their society, and so they get to choose what is it that humans want, and that distribution will look different for each of them as well. Yeah. It's a good question though. I don't know exactly if there's a better way to think about, okay, what did this look like, or any intuition there. Cool, great stuff. So I just drawn here something we'll come back to later, basically just two little pies at the top right. So what they represent is the probability of a certain response y given a certain prompt x. So if I give it x, it's going to predict y, and this pi is a probability distribution, which basically says, okay, how likely is this thing? So that's what this blue curve represents here. And we call that the policy. So this is a policy which, much like a governmental policy, says what do we do in a certain situation. The policy here is the same thing. What do we do when I'm given a certain prompt? How do I respond to that? So that's what the policy represents, and we'll come back to that later in the next section of theory. So an engineering understanding. This is just a quick one, but there are many approaches to alignment. Just something I want to be clear about. It's certainly not just the one we're all hearing about. So these are just some of the different approaches to alignment that people have tried. Some things have worked, and there's a lot of active research on this right now because it's such a hot topic. But you can do debate between two agents trying to figure out which one of them is right to find a better alignment. You can do inverse reinforcement learning, which is where instead of specifying the goal specifically, the goal for the agent is to find out what the goal is. And so it's really trying to uncover the preferences for itself. Recursive reward modeling, counterfactual reasoning, and RLHF. But right now, everyone is using RLHF. So that's what I'm going to talk about. And I'm much less qualified to talk about any of the others. So RLHF the overview looks like this. These 6 different steps. Don't need to remember these. I'll go into more detail in a second. But firstly, get a pre-trained language model. That's the first step. This one has the general knowledge of what you need to start working with large language models that are already useful, already contain a lot of general information, and kind of are as good as you can get at starting point. Then you can optionally fine-tune that to your domain. So maybe you're working in the maybe you are working in the in-world situation, trying to develop AI-powered character personalities, and you're Bethesda, and you've got like a huge data set of how you think they should behave previously, or maybe you've got chat records of different people interacting in live games. Then you could use that data to further train the pre-trained model to predict the next word on that same data set, and kind of change that distribution from generally what appears to what appears in my domain. Then you can get humans to create a data set of preferences. And this is kind of the first part, which is specific to reinforcement learning with human feedback. The process is get humans to rank which of these responses are better to a certain prompt. Use that to train a reward model, which says how good is this certain response. And then you can use that reward model to align the pre-trained model. And the idea there is that you run your pre-trained model, it produces a response to a certain prompt, and your reward model can tell it how good that is. And then you can use that to update the model. And then finally, you serve the aligned model's responses to users. So that's the kind of end-to-end process for RLHF, which looks like this, which I'll go into now. Thomas? Save that thought. Yeah, that you're going to give something away, but save that thought for a bit. Yeah. So this is what it looks like graphically, right? What's happening here? Try to do my best to illustrate the kind of process here. So firstly, you got the pre-training step. So there's just a large language model. It's trained to predict the next word, and it does that over and over again. Trained on lots of examples from the internet, and over time it can learn those general patterns. Then the fine-tuning step is where you take this to your specific gaming example. I've got the controller here. And then you have these humans rank preferences. So given a single purple prompt and multiple different responses in orange, which of those is best, which of those is worse? Are there some which was better because it said, hey, I'm not going to answer that? Are there some which are better just because they were worded more friendly? You gather that preference data set and put that in a big database so you can use that later. In the fourth step, you train the reward model on that data. So given a bunch of different, given a single prompt and a bunch of different responses, which is best, you want to predict a scalar number, which is how good is this specific response. And over time, this model should be able to achieve the task of, given a certain response, tell me how good it is. And once you know how good it is, you can figure out, okay, do more of that, please. Or do less of the worst one. And that's what you do in step 5 here, the alignment step. So given your pre-trained model, your fine-tuned model, take in prompts, make responses, and then give them to the reward model, which will say how good they are. And then after that, you can make updates to that original large language model. And then the final step is you got that model. It's time to get it in front of customers, to serve it to them. And that's where you can start actually putting into a product and really trying to solve problems with this stuff. So this is kind of, like I said, what's happening on the inside. 6 is when it gets to the outside, and that's what we'll do next week. So the implementation, how does this work? Firstly, at a high level, the executive understanding, some of the teams and tools that you need to put this kind of thing together. So this is certainly not comprehensive. There are certainly lots of other options that you could use in place of all these kind of tools here. But this is maybe an example stack which would let you put most of this together. So on the right hand side, I've got this data curation team. So like I said, you need humans to tell you how good are these different responses and rank them so that you can build that preference data set to build a reward model, which tells you how good your new responses are. And the way that, at least that's been done, proven way to do that, the way that OpenAI did that back in the day when they were first doing this, was by posting a job on Upwork. Anybody familiar with Upwork? Raise your hands. So Upwork is like a freelancer platform. You can go there, you can post a job. As a freelancer, you can accept a job, kind of like a gig economy style thing. And OpenAI was posting jobs like, hey, we need people to rank different responses and even write responses, write ideal responses for our data, for our situation, which is what they fine-tuned on. So they posted on Upwork, and then they used a platform called Scale to do the data collection. So Scale, if you were here at the last series where we did all the ChatGPT stuff in a lot of detail, we showed an example of using Scale, which is this data labeling and data management platform for AI. To give a quick overview there, you guys can look that up, but just Scale AI. So they have a bunch of different products, and within that there is some section for like how you can do data labeling. So I'll let you guys explore that, but you can log in there. You can set up problems for labelers to label. It may be, hey, you know, draw the right boundary around the object in this image. Maybe classify these images. It may be write responses to questions. And in our case, it would have been ranking different preferences between things. All of that data is stored on Scale. And then a training team or an engineering team can kind of pull that data out and begin to start doing some of the engineering which I just talked about with that. So we've already looked at Python, like everything is going towards Python when it comes to AI and data. And so, Python is certainly a big component there. A lot of the models nowadays are running in PyTorch. And so that's kind of key skill if you want to work with whether it's evaluating or training or improving those models, then PyTorch is probably the tool of use there. I've put weights and biases down here, which is a tool for visualizing the response and the progress of training neural networks. And again, there's many other alternatives, but that's a pretty common one. And TRL, I'll talk about at the end, is an open source GitHub repo for training transformers with reinforcement learning. And so that can kind of put a lot of what we'll talk about today into a box and just cover it all for you. So you don't need to worry about all of these technical details. And then you want to be able to serve that. So you can get a lot of stuff from cloud platforms like Amazon Web Services. There are services for building APIs and monitoring and training machine learning models and data storage and all those kind of things. So you can get a lot from cloud, but you could also build this yourself, and many companies are building this themselves with some of these other tools that I've mentioned here. So if you're building and running your own API in Python, you might be doing that in Fast API. If you're monitoring that, you might be doing that with Prometheus and then dashboarding things in Grafana. And a lot of that is based on NVIDIA GPUs, or NVIDIA Triton is like one of the new serving platforms. So NVIDIA have got a bunch of AI products. Of course, they make GPUs, they make the chips in your laptops, but they have different products for things like serving. So they've got this platform Triton, which is the one OpenAI uses, which is why I mention it, where you can take your machine learning model, you can plug it into Triton, and you can serve the results from that in a way that's like very scalable. NVIDIA handles all of it. It's very fast and efficient. So that's kind of some of the outline of teams and tools that you might need to put this together. Certainly not comprehensive. Anybody, am I missing anything? Probably you guys have a good idea of, what else goes into this. Certainly a lot I haven't talked about. What else do you think we'd need to make that work? Maybe what, sorry? Hugging Face? Yeah, absolutely. That's definitely one I could have put in the middle. So Hugging Face is, what is it? That's a good way to put it. Yeah. Hugging Face is like the new GitHub for machine learning, in the sense that you can publish models on there, other people can pull them down, you can have them private or shared. But a lot of the time you can't put these models on GitHub, right? Because they're getting so large. Cool. Yeah, so definitely Hugging Face could have gone in there. TRL is based on Hugging Face, and of course Hugging Face is based on PyTorch, so it all kind of fits together there. That'll be that's a really nice one. Any other suggestions of things I've missed? Either tools or yes? That's awesome. Nice, cool. And what stack did you use for that? Cool. Yeah. Yeah. That's a really great point there, because so many companies do have their own internal tools, right? I know Google obviously have their own cloud platform and internal tools. Facebook have their own, Meta have their own private cloud as well. So if you're working at Meta, a lot of this stuff is like you're not using any of this stuff. You're using the Facebook internal systems. So yeah, absolutely. Cool. And that data curation, was that also a Google in-house product? Yeah. Cool. So that would have been an alternative to Scale here, wouldn't it? Awesome. Yeah, great example, yes. LangChain, yeah, absolutely. So what does LangChain do? Yeah, awesome. So that could have probably gone in with the training team, I guess, and I don't know if it crosses over to serving as well. But cool. Cool. Maybe we'll do like a more comprehensive overview of that next week, because it seems like, yeah, I think there's a bunch of stuff we could add in there. This is just thrown together, to be honest. Cool. Any other teams or things that you think will be necessary to make this work? Anybody? Data creation, training, serving, certainly evaluation, right? Probably comes under training, but like there's a lot that we're brushing over here in terms of how important it is to evaluate these systems. Okay, how biased are they? How well do they work? All this different kind of stuff. Is it safe enough to actually put out there along different dimensions? That's a big problem and hard to do, hard to measure quantitatively. So evaluation, yeah, cool. We'll move on, but that's I think a bunch of stuff to think about there. Cool. So the labeling cost. Just wanted to touch on this quickly. If you are in a situation where you find you need to do this kind of alignment, or you need to even just gather data in general for your specific use case, then there's certainly going to be a cost to that. And the cost depends on how much data you collect. This is from one of the OpenAI papers talking about the data set size just for the reward model here. And on the from the labelers, they've got about 10,000 examples, right? They've also got a bunch of examples from their customers. To your point, Thomas, yes. And there's another point I want to touch on that shortly, but yeah, a lot of data from labelers. So if we took that 10K and did it at like 30 pounds an hour, looked like the average kind of thing on Upwork when I took a look. Let's say you can do 4 really good examples in an hour. That's 75K spent on that. So you need to have the budget to be able to do these kind of things, and that kind of product development, that's a cost of like a good engineer, very good engineer, or maybe 2. So something you need to be aware of if you're planning on building these products, that needs to be baked in to what you want to do. But of course, it depends on the application. Maybe you're doing something which is just the general knowledge in GPT straight off the API is good enough. But maybe if you're in a very niche domain or a very sensitive domain where you cannot afford to let the language model start talking about whatever it is, this is something you need to be aware of. Question? Mm-hmm. Yeah, totally. So what does the labeling actually look like, right? So I may have brushed over that a little bit too fast. So when we talk about the labeling for the reward model data set, what we have is, here's a prompt, and here's 3 different responses generated by the language model. And the labeler's job is to rank those. That's one part of the labeling process. It's the main one I'm looking at here. And that's the one in the reward model data set. So yeah, given n different examples, rank them in order. That's the kind of task you can set up on Scale. However, depending on your problem, again, there are different things that you might need to collect data for. And so you may just need like domain-specific data. You may need just the response prompt pairs themselves. You may need labelers to actually write the responses if you want to build a very domain-specific chatbot, for example. So yeah, there's the the prompt response pair collection data set. There's the response ranking data set as well. Sorry, what was the question? Yes. So like the batch of responses, that's kind of that kind of tells you, in a way, what should the reward be for each of these different responses which are produced by the model. So you kind of, if you've got these n different responses, you get n different data points really, but they only really make sense in context with each other because that's where you rank them within. Oh, sorry, no. So these labels, yeah, this is 6,000 different responses. Yeah, exactly. Yeah. So each of these will be batched together, and that's what they're compared against. Yeah. Cool. Great question. Thanks. Again, I'm probably missing out a load, guys. So if it does feel like I'm missing anything obvious, do not hesitate just let me know. Cool. Right. So just quick point on bias here. Bias of these systems, right? Your data is biased by who labels your data. That's a problem. And so here's just like some guidelines, general guidelines to talk through of what is the right approach to try and minimize that bias, right? So firstly, clear guidelines. When you set up, or when OpenAI set up their labeling task on Upwork, posted a job there, they had like really comprehensive guidelines. You can find these in the paper actually, exactly what they said to people. But it's, it's very clear about what kind of people we're looking for, which was a wide variety of people, what the task is about, kind of all different things. So basically just give as much clear instruction to people as you can so that you've got the right kind of responses coming in. Training and feedback. So make sure when you get these people on, are they, make sure they're not just like rushing through things or behaving against those guidelines. Obviously having multiple labelers and using majority voting. So not just trusting that one person's opinions are right, but also getting multiple data points on multiple opinions on the same data point, and then kind of using that to figure out what the correct vote should be. And randomization of the sequence of things they're ordering. Otherwise, you can introduce a sequence bias, which is, okay, if everybody's viewing things in the same order, they might be influenced by that order itself. Monitoring quality control, just making sure you've got good telemetry to look into how the responses are coming in. Is there anything obvious that you can see is wrong there? Making sure that your labelers are not just multiple of the same type of people, but are very diverse. So you have people from all over the globe, all different backgrounds, all different educations, all different kind of experiences weighing in on this. Again, something OpenAI is like really talking a lot about, because they're trying to build this general layer of intelligence that could be used by anybody. So what they want to be able to do is let people personalize the models on top of it, but that means they need to have something that works for everybody. Tough challenge, really tough challenge, and really important to make sure that the input to that is diverse. What do people want is obviously a function of, everybody. Ideally, we could all weigh in on that somehow, but that's really tough to do. Recommended to have a pilot phase, so don't just don't just go rolling out products which you think are what people want. Again, make sure that it's this kind of limited release so you can gather early feedback and iterate. Keep everything anonymous and confidential, obviously, and then have consistent monitoring and feedback. Kind of relates to training and feedback actually. Should probably remove that one. So yeah, those are just some bullet points on the RLHF implementation and the guidelines for labelers. So, Thomas, what happens when you hit ChatGPT's response button? Sorry, regenerate response button. Yes. So yeah, first point, you can regenerate the same response, regenerate a different response to the same prompt. And when you do that, you get a different button, which is like, which one's better, this one or the first one? And that is so that you can generate this nice loop of more data means you get a better product. The better product means you get more users. More users means you get more data. And in a flywheel, like OpenAI have built something into ChatGPT where they now have their customers giving them this feedback, which means they've reduced the cost of their labeling workforce and increased the diversity to reduce that bias. So it's on those two things, cost and the bias. I think that's like a really nice, sweet product feature that they've done, and probably has really reduced their delivery cost down to the point where it's very hard to compete with them. So that I thought was a really nice point worth mentioning. Just to highlight what that looks like, let's just go and do, again, give me 10 add taglines for ski goggles. If I run that, I get a bunch of different recommendations for my ski goggle brand. I will, yes. And I can hit regenerate response. I get 2 of 2. And then I can say, what response is better or worse? So this is where I am directly giving them this ranking feedback. Vote this one as better. That goes into the data set and it says, okay, your reward model should score this one higher. Fantastic. Cool, yeah. Very precocious picking that up earlier, Thomas. Yeah. Question, David. Yeah, I'm not sure exactly. I assume it's being constantly fine-tuned, but there's also another thing, which is that I believe when it first launched, those feedback data by default, like they were OpenAI's property, and there was a bit of a scandal where they had to retract that and say, we need you to opt in for us to use that data. So even if I've just given that thumbs up there, it doesn't mean it's going straight into the product. I'm not sure exactly the update schedule. Worth looking into. Yeah, good question though. Cool. So the RLHF implementation, what does this look like? So this is the general reinforcement learning loop, right? This has nothing to do with the language model in specific, but you have this agent, you have some robot, it takes an action to go forward. So this is the reinforcement learning loop. In general, this is how reinforcement learning works. And what we want to try and do is apply this to our language model so that it can essentially, once it's been fine-tuned, we can put it into an environment, which is like this interaction with the reward model, where it goes through the same process. So what we have is prompt comes in, our fine-tuned large language model predicts a response. You take both of those things and give them to the reward model. The reward model gives a reward, and then you use that reward to update the model. And we'll look at how that happens next. But that's the process. Cool. So, what's this? Let's just take a few-minute break here. I just want to grab a drink and sit down for a sec. So let's just so take a few minutes. I'll let you think through this. About 5 minutes.
Yeah.
All right, cool. So let's jump back into it. So I want to kind of explain what is this reinforcement learning setup here? What's this loop going on, and how do we use the reward model to update the fine-tuned language model? So the reward model, just to make it clear to everybody, right? It takes in the prompt and the response, and it gives you this this reward. This reward is just a number. It's a number for each of the different for the different prompt response pairs. Mainly the response pairs, what we're talking about, right? So we need to train that reward model based on these rankings. So the question is, how do we formulate these rankings as labels to train the reward model to predict? It should be able to take a prompt and response, predict how good that is. So the ranking loss looks something like this, which looks horrific. So I want to try and break it down, and I'm going to try do that on the visualizer. So just give me a second. Again, this might be a little bit too theoretical, but for those who are interested, switch to this. open it. Okay, cool. Right. So basically, the first thing is that you've got different responses, and each of them has some reward, right? You've got a reward 1 and a reward 2, and then a reward 3 for your different responses. And the thing is, you don't really know what number this should be. Like, what's the right value for it? How do you figure that out? All that we know is that they're in this order, right? Because that's what the labeler has done. The labeler has just organized them so that, okay, the reward 1 is at the top, reward 2 is at the bottom, reward 3 is at the bottom. So it doesn't actually matter the absolute value, it just matters the relative value. What you should have is reward 1 is bigger than the others, right? So we don't have an exact label of this is the right number, we just know this is the right order. So what that means is that we know that reward 1 is greater than reward 2, and reward 2 is greater than reward 3. Okay? And if we know those things, well, then you know that reward 1 minus reward 2 should be greater than 0, and so on. So this is what we want to try and make sure is true, right? And so thinking about, okay, what do we try and maximize if this is the goal? We have some objective we want to achieve. How do we make sure that's as big as possible? The thing which we achieve, which is the equation which I just drew there, is something like the average. That just means the average log of this function, the sigmoid, of the difference between these two. So let me break that down. So that's just what you saw in the equation. So this is the objective. So basically what you want to do is maximize that thing. So what are the different parts of this? Well, this part is what I just explained. We know that this should be greater than 0. And this thing here is this sigmoid function, which looks something like this. So from negative to positive infinity, it goes along very close to 0, and then up here it goes up to 1, something like that. So that's what this function looks like. What it means is if the input is bigger than 1, then it's going to be close to, the output's going to be close to 1. If the input's less than 0, then it's going to be close to 0. This function, the sigmoid, is typically used to turn any real number into a probability, because it puts it between 0 and 1. And so what you can think about is that this thing here, this is like the probability of reward 1 is greater than reward 2. So that's the thing we want to make bigger, right? We want to make that the probability of the first reward being bigger than the second. And so a typical way to do that is to take the log, like a bit of it. The log function, again, don't worry about this too much, it's just a theory. Log function looks like, it looks like that, crosses the axis at 1. And so if we know that our examples are always going to be between 0 and 1, because the output of this thing is always between 0 and 1, then the example is always going to be in this range here. It's always going to be somewhere in there. And so, so that should be minimized, actually. So I always want my, the difference here to be as close to 1 as possible. Sorry, no, I was right. That was actually maximize. Take that back again. We do want to maximize that thing. So we want this difference to be as close to 1 as possible, because what that means is the difference is very positive. It's over there somewhere. So we want it to be close to 1, and so taking the log of that thing is just what we want to maximize. And then we just do that over lots of examples. So given lots of different response pairs, we just take the average of this function. And that's the thing that we try and maximize. So I won't go into it here, but we can do that with gradient descent. And that's how that's how the reward model is trained. That's the goal for the reward model. It's to take different response pairs and take the difference, take the sigmoid, take the log, and push that thing up. So looking at how you change the parameters of the model, change them in a way that makes this number bigger. So I'm happy to go into that in more detail if somebody wants maybe later, but don't want to focus on that for now. But that's the objective of the reward model. So that's what that is there. And this prefix over here is just the number of different response pairs that we give the labeler. Any questions about that? Take my time. Cool. I'll share it with you guys later, so no worries about it now. So then how's that used to actually update the model? Once we have this reward model that can correctly predict some number for each different reward, and the higher the ranking, the higher the reward. Once we've got that reward model, how is it actually used to update the fine-tuned model is what I should say there. And this is done by a reinforcement learning algorithm called proximal policy optimization, PPO. And so when you read the papers, you see this, which looks even worse than the last one. So to break that down, firstly, just an overview, intuitively, if you want just the one-line takeaway intuitive sentence, you can say this. The objective to be maximized is the expected reward penalized by the scale difference between the new language model and the original language model. So let me break that down a bit, right? It's basically, you want to maximize this reward. That bit's kind of obvious. But the thing is, you don't want the new model, the one trained with reinforcement learning, to be too different to the old one. Because this supervised fine-tuned model, that one's like really good at the language modeling. So it's got a lot of the knowledge. You don't want to just learn to model the reward function. You want to keep a lot of that knowledge there. So you don't want these things to change too much. And so this term over here, you would call it the KL divergence between the two distributions. You don't want it to go too far away. It keeps the final model somewhat close to the other model, but at the same time, this overall objective maximizes the reward whilst doing that. And then there's this parameter here, this beta, which just controls the strength of how closely the model is forced to stay close to what it was originally. So that's how that looks. And again, it's not really that important. We can go way over this and abstract away from it. But I think it is interesting because this is kind of one of the key equations, which is powering the breakthroughs in AI right now. So if you want to understand what's the math behind AI that's working to the degree it's working right now, that's part of it. So it's funny, you can get away by just optimizing that equation. And when you think about how big of an impact that's had, it's actually quite nice that it breaks down to an equation this small, even though it does look complicated. So if you guys are up for it, I will do a speed run derivation of proximal policy optimization, so you can just see kind of where that comes from, right? So just bear that in mind. It's how did we get there if we were trying to figure this out from first principles? Because it's not obvious that that's exactly how you should measure it. There are other ways you can compare the difference between two distributions. There are other ways you could scale them. So how did we get to there? Let me show you that. I'm going to speed run it. Try and do this correctly as well. So basically, the objective that you want to maximize here, call this thing J, to start off with, this part is quite intuitive. It's just the average. It's the expected. What's the right way to say this? So if we were to look at lots of different trajectories, I'll call them T, tau, generated by the policy pi. Sorry, I can do this bigger. So I've got this big objective, and I want to take an average of, okay, when I generate different response prompt response pairs, and they come from my policy pi. So that's basically just some probability distribution that I mentioned earlier. That's the key thing, right? This is some probability of generating a prompt response pair. If I use that model, I can sample different prompt response pairs from it. So it's basically just if I give my language model a prompt, what does it give me back in response? That's what that tau is here. And if I just sample that a lot of times, I get the average. So what I want to average, the first attempt here would be to say, okay, let's imagine I had a labeled data set, right? So what you want to do is you want to you have this probability of a certain response prompt pair in your data set. So you know it's a real example. Some human has written this example. Then you know you just want to maximize this thing, right? So this would be the supervised learning case. This is the supervised learning case where you're basically saying, all right, I've got all of these in a data set, which I know they are correct. So what I want to do is maximize the expected probability of my model, like writing one of those response prompt pairs, right? Because if it writes one of those, well, then it's writing like my labeler would write, the labeled data set. So the problem with this is that you need a lot of data. You need that big data set to actually to have those response prompt pairs. And so that's kind of how we did the fine tuning. Not exactly with that objective, but something slightly different. But then there's a question of, well, if we say we didn't have a labeled data set, but we could just randomly generate response prompt pairs for our model, how would we tell it what's good and what's bad, what's gibberish and what's not? Well, what you'd probably do is basically scale that by the reward given to that response prompt pair, right? So what this says is maximize the average probability if they are good. So if they're good response prompt pairs, that is like they have a high reward, then you're going to say increase the probability of showing that response prompt pair, right? Anybody have any questions so far? Because that's the backbone of proximal policy optimization. Probably going in a little too deep here, so don't worry about it. We'll be through this in a moment. But I think it's kind of interesting. So yeah, basically, again, just one more time to reiterate this. What we're saying is maximize this thing. What that means is maximize the average probability of things which give you a high reward. Okay? If they give you a low reward, if this number is like 0, well then I'm not gonna try and maximize that prompt response pair, right? If this reward is very high, then that adds a lot to my objective. So I want this thing to give me a high probability for that for that high reward prompt response pair. So, then the issue is that you need to sample from your current probability distribution. That is whatever your parameters are right now. So that means every time you change the model, you can't use data that you've collected in the past for this model because they came from a different distribution, which wasn't this one. So you can use a trick called importance sampling to change this distribution into a different one. So I can say, right, I'm gonna multiply all of this by a new distribution, which is my original distribution divided by itself. That's just 1, obviously. I've done this slightly wrong. Essentially, you can end up with something that looks like this. I won't go into the details now because I feel like I'm getting over my head with it, but you can sample from your old distribution multiplied by a different one. I've done something slightly wrong there. Yeah, that's what I mean. Yeah, so yeah, you should have units. Yeah, so that divided by pi prime. That's what I want there. So what this means is you can sample from your original model distribution instead of and that means you can use your old data, which was response prompt pairs from that original distribution. So basically just a trick to mean that this algorithm becomes what you call off policy. It doesn't need to use the data, which is using the current policy to generate responses. And then from that, where do we go? Well, we have this expectation thing, and if we want to maximize this thing, we can also maximize the log of it. The log again is a function that looks like this. Oh, start that. Because this function's always increasing, the way to maximize this side is just maximize the input, because for any given input, the output's going to be bigger if that input's bigger. For any other input, the output's going to be lower. So maximizing this is the same as maximizing the log of all of that. And then you can use this rule, which is the log of some product AB is equal to log A plus log B. We're getting a little bit closer now to the equation we saw in the paper, right? So what that gives you is average the log of these pi ratios, probabilities of your new model relative to your original model, plus the log of the reward. And now you can see we separate out those two terms, which is what we saw in the original equation. Again, maximizing the log is the same as maximizing its input, so you can remove that thing. And then what we can do is rearrange that so it looks like what we had in the equation. So I'm going to put the reward on the left, and you can use another rule here, which is the negative log of A over B is equal to the log of B over A, and then flip that upside down and add a negative sign in front of it. Looks like that. So that is the objective which you come up with in the paper, right? So I know that's a lot there to go into right immediately. But for those who maybe mathematicians or wondering where that theory comes from, that kind of breaks it down from what I think is a more intuitive place of like maximize things which give you maximize the probability of things which give you a high reward, all the way down to what you see is maximized in practice. So that's the thing which actually appears in the equation, is implemented in the code, and then this is the goal, which is then minimized with gradient descent in the training here. Are there any questions? Yes. Yeah. So pi prime is the your model after each optimization step, right? So what other way around? Yeah. Oh, no, sorry. Pi prime is your original model, I believe. So at the top here, we're sampling from the model as it is. Like that's the most recent updated model. And but to do that, we need to have response prompt pairs that were generated by that model. That means it needs to be on policy. The data needs to come from the current model. So what we did was we switched that out with if we can sample from the original distribution, which we have the data for, then that would be better because we got that data. And then switch that out. And so now here, that pi prime is your original supervised fine-tuned model. And then this one is just the probability generated by your current model. That's the question. Cool, great. Yes? You're asking the wrong person. Maybe, but I'm not sure. Cool. Great, all right, that was tough. So let's move back over here. All right. So that's really most of what's happening there. And that I think if anybody was here last time we did this as well, that kind of covers a misunderstanding which I had at the end. So like this is the objective which you're trying to maximize, and it's done using that process basically. I could talk more about that with anybody else who wants to see it later, but that is correctly how it's done. So the engineering understanding here, what's happening? Well, I've kind of already touched on this, so I'll skip through it kind of quickly. But we've got this human preference data set collection. So we have humans found an Upwork. They are asked to do this job with a very clear spec, and then they do that on scale. That gets us all the data, and that's what gives us those ranking pairs in in the reward model part of the system. So all of that, kind of to tie things up, we're almost finished here, so we'll begin to wrap up. To tie things together, there's this library called TRL, which I have an example which I'll leave you guys with after this session. And what this is a library which kind of packages all of this together so that it's rather easy to implement yourself. So if you did want to build a product that needed you to align large language models and you wanted to run that process of training a transformer with proximal policy optimization, you wouldn't need to write out my horrific equation there in code. Instead, you can just use TRL. And TRL, that's where the logo comes from that I showed earlier. TRL has a quite a simple wrapper around the whole process there that you can basically boil all of this down into a set of code like that. So you can get this PPO trainer, which is it contains all the proximal policy optimization, all the details there, and it's configurable in a very abstracted way. You can use that to simply create the config there, and then create that trainer. You pass in the model. You pass in that model and some other configuration, and then you just ask it to do .step. So you'll run this in a loop to take proximal policy optimization steps. Each time you give it the query which goes into the model, and you give it the response which is expected, and then you give it the reward. The response which is generated, and then you give it the reward. And that reward comes from our reward model. So plugging all of that into there, you can just put that in the loop and then run it. And so this is the other notebook which you can find in here. I think I'll leave you guys with this now, kind of look over it in your own time, or I can talk about it with anybody after. But if you open up this notebook, I'll send this out in the follow-up email as well. There's an outline of how this process would actually look. So we've got the import TRL, etc. There's two quite big cells there which define the language model and the reward model. But at the end, there's the important part, which is new, which is using TRL. So you get the reward model, get the SFT model, supervised fine-tuned model, and then you can basically run that through the same process as shown in the TRL documentation to put it into something which would look like this. This is a work in progress, so I haven't tested the final results of this, but here's the outline of what this would look like once you implement it. You've got the configuration for the proximal policy optimization, you've got that trainer, you've got a function which trains and saves this new fine-tuned and aligned model. And then you go through a number of epochs, a number of different runs of the data set, and it should be a number of different batches of the data set in there as well. And you pass it in text, pass it in a tensor, go through that process, and do that step. So this is what I'm saying. You do that step in a loop over many different batches. So I would say something like here for batch in data loader. All of that stuff, I would do that for every different batch of input prompts. And after I've done that, I should have this model which has used the reward model to become more and more aligned. And that's the kind of thing that you see plugged into ChatGPT. That's the kind of thing that you see plugged into Viable and Inbound that keep it within these constraints that make it behave in the way that you want, that's useful, truthful, and not inappropriate. So with that, that's really kind of one of the last things I got to wrap up with, other than to show you the next level of that, which is TRX. If you want to do this on a bigger scale, you can use TRLX, which is a distributed training framework for scaling up TRL. Visit this as well, check it out. You can read through the documentation there, but it basically lets you do the same thing, running that optimization process, but you can distribute that to a large cluster of computers, so you can do it in parallel, and you can plug in kind of tools which are typically used to do that, like Ray. Ray is a tool used for distributed training of large neural networks. So that's another thing which I'll encourage you guys to look into. But if you want the hands-on practice, I'd recommend to take a look at the second notebook in there. And if you want a starting point for building a product with this, doing some of this alignment yourself, this could be a good place to start. So And I'll be happy to work with anybody who wants to contribute to this. Just let me know, make a pull request on GitHub. So with that, thank you for your attention. Is there any more questions anybody wants to go through now on the end of that? Mm-hmm. Mm-hmm. Yeah, so what does that cycle look like? So what you're talking about there is kind of outside of the alignment process. Doesn't sound like that's what you'd need, unless you want to add that on the end. But what the part you're talking about would look like is over here. So this would be kind of steps 1 and 2, right? You have firstly a pre-trained language model. You could get this off of Hugging Face, or you could use the OpenAI API to use GPT-3 as a starting point. That one's already got all the knowledge of the internet on. And then on top of that, you could have your own data set, which is just text within your domain. And you use the same model to further train and say, hey, predict the next word in this data set. That kind of customizes it to that particular domain. And that could be prompt response pairs, if you want it to kind of learn that chatbot style back and forth behavior as a starting point, or it could just be large bodies of text which you're predicting the next token for. And that will help you build a good language model, but it won't behave in the way that you want, where you can instruct it to do things, right? It will just follow the next text on. So this is the kind of situation where, we said explain the moon landing to a 6-year-old, and the response was explain quantum to a 6-year-old. That's not really what we wanted it to do. We wanted to explain the story. And so the alignment is the next step, which helps it do that. So if you were looking to not just model the language, but actually to create an instructional agent, one that responds as you tell it, that's what alignment does. Alignment makes the model do what you say or do what you want, not just continue what you said. Does that fill in the gaps there? Awesome, cool. I'm happy to talk more about it after if you want. Yep, David. Yeah, absolutely. Yeah, and so that's the kind of point in the loss function here. You've got this beta term. Yeah, you are. But that's really the whole point of this term. Is the larger beta is, then the bigger the penalty for these things being different. If those are the same distribution, then this whole term will be 0, basically. It'll be the inside will be 1, and that'll be a very low value once it goes into the log. So the larger that beta is, the stronger the incentive for the model to not move too far from the distribution which it started from. And you imagine the shapes of those distributions. What RLHF is doing is like clipping off the points that you don't want to have high probability and trying to push the data set in the direction where you want it to increase the probability of how it responds there. So yeah, absolutely, there is risk, and that beta is something you'd need to tune. Maybe you run several experiments, you have human evaluators after who are ranking, okay, which responses are preferred from which model, and you test that with a varying number of different beta values. Great question. Cool. Yes, go for it. Mm-hmm. Yeah. That's a good question. I don't know off the top of my head. I think, yeah. Write that down and send it to me, and we can look into it. That's a good question. I don't know the answer straight away. Cool. Great stuff. Yes. Yeah, absolutely. There are, in fact, let me show you this this paper, which is a really good reference. So this is the Instruct GPT paper, which is kind of, you know, a lot of the original work on RLHF, not on RLHF, but a lot of the original work on the Instruct GPT models comes from here. And in here, I believe they've got some performance metrics on different kind of things. Yeah, so I mean this is one, right? So there's this thing like the perspective API is something you can use to get the toxicity levels of different responses, and a human evaluation you can do as well. So these kind of things, like these are maybe more qualitative ways that you can measure how good is the model, because you're absolutely right. You don't want to base the performance on how good that final value is, because this is arbitrary, really. The absolute value here doesn't matter here. This is just a proxy for if you maximize this thing, you hope that the model will better represent human preferences. The real test comes down to things like this. Why don't we just optimize on this? Well, because this is not a continuous mathematical function which we can differentiate. So this one, you know, you can't optimize directly. And there are a bunch more in here as well, actually. I can't remember what they are off the top of my head, but I'll share that in the follow-up as well. But there's a whole table with different metrics in, and I think there's another OpenAI blog post about it as well. I'll share that after. It's called Instruct GPT. If you search Instruct GPT paper, it comes up. It may be called something else though. Yeah, I will do. Awesome. Cool. Look, I think yeah, that's everything I want to go through. I'll leave you with the I'll leave you with that. But I also wanted to announce one thing, which is I have another event planned. I have another event planned at the end of this month, and it's going to be the first AI Insights Summit. I've got a really epic location in Shoreditch in London. So if you're available this time, 3 weeks from now, I think it'll be more in the evening. We're going to get a big crowd together, people from AI Core, people from the previous lectures, people from a bunch of different places. And we're basically going to go through showcasing the research that we've done in the past few months on the state of AI in industry. So this will basically showcase the key things you need to understand about what the requirements are for different jobs in the key roles of AI and data. We're going to go through what is currently the 6 principles that you need to know to position yourself in the future as AI really evolves things. And then we'll go through what is currently the 9 questions that we think you need to ask yourself to understand where you fit. So that's the idea. There'll be me sharing some of that. There'll be one of my friends who's a machine learning engineer from Google sharing some of that. There will be another one of my friends who is a super senior VP of engineering at about 4 different companies now, including a super huge insurance firm, including Faculty AI, including a bunch of other places too. So it'll be really awesome. I'll share the details of that in the follow-up email as well. But I just wanted to announce that to you guys here. Yeah, please come along. I'll follow up with the details of that as well, because there's a code which I can give you. So with that, I'll leave you guys to it. Thanks so much for giving me your time on Saturday. I'll be here next week. Thank you. Ooh. If there's any questions, feel free to come and grab me now.